Way back in 1901, some divers were exploring an ancient shipwreck off the coast of a Greek island, Antikythera, and they found something, well, something impossible. It was this corroded lump of bronze filled with intricate gears, and it had scientists scratching their heads for over 100 years. We're talking about the Antikythera Mechanism. It's an artifact so advanced it feels like it literally fell out of time. Today, we're going to crack the code on what might just be the world's very first computer.
I mean, really think about that for a second. This little clockwork machine with its web of bronze gears is more than 1,000 years ahead of its time. It completely rewrites the timeline of technology and makes you wonder, what else did the ancient Greeks know that we've just lost to the pages of history?
So, in this explainer, we're going to play detective, following the clues just like the researchers did. We'll start with what we thought we knew, then zoom in on one tiny rogue gear that turned out to be the key, and you'll see how solving that one little puzzle completely changed how we see this incredible machine.
Now, for decades, we've known the Antikythera mechanism was an astronomical calculator of, frankly, staggering genius. This wasn't just for telling you the date. No. This was a miniature model of the cosmos, designed to track the incredibly complex dance of the sun, the moon, and the stars. The sheer power packed into this device is just wild. It could track the sun and moon, it had a calendar for the ancient Olympic Games, and it even modeled the moon's weird, wobbly orbit using this brilliant little pin and slot system. It was clearly built to be a master eclipse predictor. But here's the thing. There was a huge, glaring problem. A key piece of the puzzle, a gear system you absolutely need for that job, was just missing.
And that brings us to our number one suspect. Among all the bits and pieces recovered from the wreck, there was this one little guy, Fragment D. It's a small gear that just didn't seem to fit anywhere in the model scientists were building. For years, they tried to figure out where it belonged in this impossibly complex machine.
So you've got this real conflict, a total paradox. The most popular theory was that Fragment D was for tracking the planet Venus. But that felt off. I mean, the whole machine screams Eclipse predictor, yet it was missing the one gear it had to have for that, a gear to track something called the Draconic cycle. It just didn't add up.
And that's where modern tech comes in and totally changes the game. Using high-powered 3D X-ray scans, researchers could peer right inside the corroded metal without ever touching it. And deep inside, they found something tiny but absolutely monumental, a single 1 millimeter thick pin that made the whole Venus theory mechanically impossible. They even gave the problem a name, the seesaw effects. See, this little stabilizing pin wasn't on top holding the gear down like it should have been. It was wedged between the gear and the plate it sat on. This meant the gear could never, ever lie flat. Every time it turned, it would just wobble back and forth, like a seesaw. So let's just walk through why this is a deal breaker. That tiny pin creates a permanent gap. Because of that gap, the gear can never sit flat. And because it can't sit flat, the second it tries to turn, it just wobbles and pops right out of alignment with any other gear it's supposed to be driving. The whole setup was so unstable, the researchers realized the Venus theory was a non-starter. It just could not have worked. Okay, this is where the detective story gets really good. If Fragment D wasn't for Venus, then what was it for? This was the big aha moment. A new theory popped up that didn't just solve the mystery of this one little gear, it solved the mechanism's biggest paradox. All right, so this quote really gets to the core of why that missing gear was so important. To predict an eclipse, two things have to happen at the exact same time. First, you need a new moon or a full moon. Simple enough. But, and this is the key part, the moon also has to be crossing the same path the sun takes across the sky. The time it takes for that to happen is called the Draconic month. If you can't track that, you can't predict eclipses. End of story. So here's the new theory, and it's just so beautifully simple. Forget Venus, Fragment D was the missing piece everyone was looking for. It was the Draconic gear, the absolute key to the whole eclipse prediction system. And guess what? The researchers found a perfect, previously unused spot for it right in the machine's gear train. And here is the kicker, the proof. When they modeled this new setup with Fragment D in its new home, the results were just breathtaking. This number you're looking at, that's the error, just negative 2.9 minutes per Draconic month. Let that sink in. For a 2,000-year-old machine built by hand, that kind of accuracy is almost supernatural. It wasn't just a good fit, it was a perfect fit. But this wasn't just about one gear. Oh no. Finding its home set off a kind of chain reaction. It was like finding the Rosetta Stone for the whole device. It forced everyone to take a fresh look at another major feature on the back of the machine, the huge Saros Eclipse spiral.
It turns out the ancient designer loved symmetry. Based on how certain bars were placed on the backplate, the researchers could precisely recalculate where all 223 little cells on that spiral should be. And their conclusion? The old numbering system was off by exactly 1 cell. Every single eclipse prediction had to be shifted over. And this is where it gets really cool. Correcting those numbers revealed a fundamental rule of the machine's programming. An eclipse on the new cell 113 suddenly marked the exact halfway point of the whole cycle. And mathematically, that can only mean one thing. The cycle's starting point, cell number 1, had to begin with the opposite event, a solar eclipse. This wasn't random data. It was a perfectly balanced, intentional design. So, all of these clues, the seesaw gear, the Draconic cycle, the renumbered spiral, they all lead to one final and honestly profound conclusion. It completely reframes what this machine was actually built to do. For the longest time, everyone assumed the big main dial on the front, the Zodiac dial, was divided into 360 degrees to show you the sun and moon's position in the sky, units of space. But what if that was all wrong? What if it was actually divided into 365 parts to represent the days of the year? That tiny shift changes everything. The machine isn't just a space finder, it's a time machine. And suddenly, it all clicks. If the main dial measures days, then every single dial on the Antikythera mechanism is measuring a unit of time. You've got days, months, years, the works. This design even lets it model the unequal length of the 4 seasons perfectly. It wasn't just mapping where things were in the sky, it was a sophisticated computer built to calculate when they would happen. Which brings us to one last absolutely mind-blowing thought. The researchers figured out that the machine was designed to calculate future eclipse events on its own, which were then engraved onto the dials. In a way, the machine was learning or being trained to make these incredible predictions. And that led them to ask a wild question. Could this 2,000-year-old clockwork of bronze be the very first application of machine learning in all of human history? It's a thought that doesn't just change our view of ancient tech, it changes the history of ideas itself.